Hi everyone, welcome to another video. Today we are going to look at a CXC CAPE Unit 2 past paper question taken from the year 2013. Let us begin. Figure 1 shows two reactions of compound X, which is a vegetable oil. This is compound X and the condition required to produce P, and again compound X and the condition required to produce Q. I went ahead and rearranged compound X for a simpler view. Now, compound X is a fat molecule, and fat molecules are produced from fatty acids and glycerol, which is an alcohol. So that's an esterification reaction. So fat molecules are actually esters. Let us look at the first question, which asks us to draw the products formed at P. So these are the products formed at P. A trialcohol, which is glycerol, and an organic sodium salt. So those are the products at P. The products formed at Q, also glycerol, which is the trialcohol, and a methyl ester. The methyl group here, so it's a methyl ester. Part 3, identify the process which leads to the formation of the products at P and Q. So at P, base hydrolysis is needed, was used to form the trialcohol and the organic sodium salt. Hydrolysis is a typical reaction for esters. It can either be base hydrolysis or acid hydrolysis. If it's an acid hydrolysis, then the alcohol and carboxylic acid is produced. If it's a base, then the alcohol and the salt of the organic compound is produced. The salt of the organic compound is produced. In this case, we have sodium hydroxide that was used as the base, so the sodium organic salt is produced. Part B, transesterification is used to form the compounds at Q. And transesterification simply means that is a process that involves the R groups in an alcohol exchange with the R group in an ester. So here you have the R group from the alcohol, from the methanol, and it was exchanged with the R group from the ester. So that's transesterification. Part 4, state a use of the non-alcoholic product formed at P and Q. So at P, the process is saponification, and the sodium organic salt is used in the production of making soap. And at Q, the methyl esters, they're actually biodiesels, and so they are used as fuels for energy. Next up, part B, a student was asked to identify the organic compound Z. Table 1 shows the student's incomplete record of tests conducted on Z. Complete the student's record by writing the correct observation or inference in the appropriate space. So we look at them individually, starting with A. Compound Z was mixed with 2,4-dinitrophenylhydrazine, DNPH, and the student inferred that Z is a carbonyl compound. So what observation should we expect from A in A? A reddish orange PPT, or it can be yellow. So yellow, red, or orange, those are usually the typical color observation for carbonyl compounds with DNPH. At B, the student added to compound Z acidified potassium permanganate and then heat it, and the student inferred that Z reduces KMnO4, so compound Z is actually a reducing agent. So what observation should we expect from that? Potassium permanganate, which is a purple solution, purple mixture, it would change to colorless when it is reduced or when it oxidizes other compounds. and compound Z would be oxidized to the carboxylic acid. If ketone is present, the carbon to carbon bond is destroyed upon oxidation. Why that takes place is that ketones typically are resistant to oxidation. However, ketone will undergo oxidation if the oxidizing agent is very strong, such as potassium permanganate. And so, due to the absence of the H, the terminal H in a ketone, the carbon to carbon bond would be cleaved or be very destructive upon oxidation with the potassium permanganate. Part C. To compound Z, the Tollens reagent was added and the student observed a silver mirror appeared. So what can we infer from that? Well, the silver mirror test or the Tollens test, the aldehydes, they would react with this test, and while ketones, they do not react with Tollens test. So an aldehyde is suspected. So we are getting more specific. So we start from the carbonyl compound, which is the C double bond O. Now we are being more specific to which carbonyl compound, and in this case, based on the test with the Tollens reagent and compound Z, an aldehyde is suspected. Let's look what D has to offer. So to compound Z, the failing solution or the failing test is added, and the student realized that there wasn't any reaction. There weren't any reaction whatsoever. So what can the student infer about compound Z? Now, all aldehydes would react with failing solution, with the exception of aromatic aldehydes and the ketones. Ketones do not react with aldehydes. Ketones do not react with failing solutions. So we definitely know that the compound is not a ketone. Failing solution is used to test for reducing sugars and the presence of aldehyde groups. However, aromatic aldehydes do not react with failing tests. Why this is the case? If you look at the structure of the benzene molecule, the delocalized pi bonds may account for benzene unusual stability. So because of those delocalized electrons, the benzene molecule is extremely stable, and because of the failing solution not being such a strong oxidizing agent like the Tollens reagent, then no reaction at all would take place with the benzene aldehyde. And part 2 wants you to draw the likely structure for compound Z. So compound Z is benzaldehyde. So look right here, you have the terminal H. If this H were a CH3, then it would be a ketone. So that's the difference between ketone and aldehyde. There are no hydrogens in ketones, right? But there is a terminal hydrogen in the aldehyde. So this is benzaldehyde. Alright, moving on to the next question. Part C, the reaction between carbonyl compounds and hydrogen cyanide occurs via nucleophilic addition. And you can see right here where the nucleophile in the form of the cyano group is added to the carbonyl compound to produce the cyanohydrin. So they want you to outline the mechanism for this reaction. And they want you to also use curved arrows to show the movement of electrons. So before we begin, let us look at what we are working with. Hydrogen cyanide is a very, very weak acid. It produces very little H plus or hydroxonium ions in solution. Now, due to the electronegativity of the nitrogen atom present in the hydrogen cyanide, the polar ends are formed. So the electron density spends most of its time right here on the cyano part of the compound, and so that develop a positive end where the hydrogen is and a partially negative end where the cyano group is. So partially negative at the hydrogen and partially positive end at the hydrogen and partially negative end at the cyano group. Now I also want you to know that once the cyano anion is produced, the electron taken from the hydrogen, from the bond between the hydrogen and the cyanide, the electron is actually on the carbon and not the hydrogen, and also the charge is also on the carbon and not the hydrogen, the nitrogen. So let us see what happened. So the carbonyl group right here also has polar ends. Oxygen being more electronegative than carbon would pull the electron density closer to the oxygen atom, and that developed a partially negative side and a partially positive side where the carbon is concerned. So look at what happened. When the cyano ion attacked the carbon of the carbonyl group, the electron, the pi electron within the bond sense the cyano coming in, and so it would move onto the oxygen. As you can see, the pair of electrons move to the oxygen, and so an alkoxide intermediate is produced. This alkoxide intermediate then pick up an hydroxyonium ion. Water is a very good leaving group, so the H from the hydroxyonium ion would attach to the oxygen, and water would end up leave in the process, and that produced the cyanohydrin compound you see there with water molecule as well. So those are the steps involved in the production of the cyanohydrin, or the reaction with the carbonyl compound and hydrogen cyanide. So we'll stop here for today. Hope you have enjoyed it. I hope you have learned something, and I do hope that you are studying very hard and smart to be very successful in your exams. Remember to share the video, subscribe to the video, and like the video. Thank you for watching, and see you real soon.